Hi, good evening students. Today we are going to discuss the topic differential equation. First, we have to define what is differential equation. Differential equations includes derivatives of the dependent variable with respect to independent variable. That means in an equation consisting of derivative part, that means let us consider dy by dx plus 5y equal to 0. Now here in this equation, we can see one derivative part, that is dy by dx. Here y is called a dependent variable and x is an independent variable. That means here we have to differentiate a dependent variable with respect to an independent variable x, that is dy by dx. It is denoting dy by dx. Therefore, an equation consisting of a term dy by dx, it is called a differential equation. For example, d square y by dx square plus dy by dx equal to 0, or dy by dx equal to minus xy. Then dy by dx plus xy equal to 0. That is, here the differential equation means an equation consisting of a derivative part. Here the derivative of dependent variable with respect to an independent variable. Here we have to discuss only an ordinary differential equation. That means in this equation, the derivatives of dependent variable with respect to only one independent variable. That means in the ordinary differential equations, we can see only dy by dx, d square y by dx square, d cube y by dx cube. That is first derivative dy by dx. Second derivative d square y by dx square. Third derivative d cube y by dx cube. That means one dependent variable with respect to one independent variable. Therefore, in this chapter, we have to discuss ordinary differential equation. Therefore, the equations of the form dy by dx equal to, or d square y by dx square plus dy by dx equal to 0, like that. Next, we have to define order of the differential equation. Let us consider a differential equation dy by dx equal to 2x. Now, this is the differential equation with the first order derivatives. That is, dy by dx is first order derivatives. Next, we can consider another differential equation d square y by dx square plus dy by dx whole cube equal to 0. Now, here first order derivatives and second order derivatives are existing. That is, dy by dx is the first order derivative and d square y by dx square is second order derivatives. That is, first order and second order derivatives are existing. But when we define the order of the differential equation, we have to considering the highest order derivatives of the differential equation. Here, the first differential equation only first derivative. Therefore, the order of this differential equation is what? Order is 1. That is order of the highest derivative. Here only first order derivative is existing. Therefore, the order of the differential equation 1 is 1. Next, consider the second equation. D square y by dx square plus dy by dx whole cube equal to 0. Now, here we can see two derivatives, that is dy by dx and d square y by dx squares are existing. That is first order and second order derivatives existing. But here we have to considering the order of the differential equation. That means the highest order of the derivatives we can calculate. Here d square y by dx square is the highest order derivatives. Therefore, the order of the differential equation is what? Here order is 2. Consider next equation d cube y by dx cube plus 5 dy by dx plus y raised to 6 equal to 7. It is another differential equation. Here we can see the derivatives are first order and third order. Now we can find out the order of the differential equation. How can find out? Here the highest order of the derivative is the order of the differential equation. That means the order of the differential equation is the order of the highest derivatives of the dependent variable with respect to independent variable. Now here the highest derivative is what? D cube y by dx cube. Therefore, the order of the differential equation here, it is the third order derivatives. Therefore, to define degree of the differential equation, first we have to consider degree of the polynomial equation. How can find out the degree of the polynomial equation? In the case of degree of the polynomial equation, it is the highest exponent of the variable. That is the degree of the polynomial equation. Let us consider p of x equal to x square plus 2x plus 1. Here we can check the highest exponents of the variable x. Here the highest exponent is 2. Therefore, the degree of the polynomial equation is 2. Now, we have to consider degree of the differential equation is expressed as the form of a polynomial equation with derivatives. That is, it consisting of a polynomial, that is, it has a polynomial equation with derivatives dy by dx, d square y by dx square, d cube y by dx cube existing. That is dy by dx, it is denoted by y dash. D square y by dx square, it is denoted by y double dash. Then d cube y by dx cube, it is denoted by y triple dash, like that. Or it is also denoted by y1, y2, y3. Some questions are like that. 5y1 plus 3 d square y by dx square plus 3y equal to 0, like that. That means here first order derivatives y1, 5 dy by dx plus 3 d square y by dx square plus 3y equal to 0. That is, in this case of differential equation, that is, the differential equation is expressed as a polynomial equation with derivatives also. Now here, how can you find out the degree of this differential equation? Here we have to consider the highest order derivatives. Which one is the highest order derivative? Here, second order derivative, that is d square y by dx square. Next, we have to consider the power of that highest order derivatives. For the degree of the differential equation is what? Here, d square y by dx square raised to 1. That is the power, its power is 1. Therefore, the degree of the differential equation is what? Degree of this differential equation. Degree of this differential equation 5y1 plus 3 d square y by dx square plus 3y equal to 0. What is 1? That means it is the highest power of the highest order derivatives. Here highest order derivative is d square y by dx square and its power is 1. Therefore, the degree of the differential equation is the highest power of the highest order derivatives. Special note, log dy by dx, sine dy by dx, e raised to dy by dx. These are not the polynomial functions with derivatives. Therefore, the degree of these differential equations are not defined. This degree of these differential equations are degree of these type of differential equations. These differential equations are not defined. That means sine of dy by dx, cos of dy by dx, tan of dy by dx, log of dy by dx, e raised to dy by dx. The degree of this type of differential equations are not defined. We have to define degree only on polynomial equations with derivatives. That means some functions with sine y, that dy by dx plus sine y equal to 0. These equations has degree defined. Here sine y, it is a polynomial function. Consider the question, determine degree and order of the differential equation d square y by dx square equal to cos 3x plus sin 3x. In this differential equation, the highest order derivative is d square y by dx square. Therefore, the order of the differential equation is 2. Highest order derivative is d square y by dx square. Therefore, order of this equation is, order is what? Order is 2. Next, find out the degree of the differential equation. This is a polynomial equation in d square y by dx square. Therefore, the power of d square y by dx square is the degree of this differential equation. That is, here the power of d square y by dx square is what? 1. Therefore, this is a polynomial equation in d square y by dx square. And the power of d square y by dx square is what? And the power of d square y by dx square is, in this differential equation, the power of d square y by dx square is what? It is 1. Therefore, the degree of the differential equation is what? Degree is 1. Next question, determine degree and order of the differential equation. D raised to 4y divided by dx raised to 4 plus sine of y double dash equal to 0. Here, the highest order derivative is d raised to 4y divided by dx raised to 4. Therefore, the order is 4. Highest order derivative is d raised to 4y divided by dx raised to 4. Therefore, order is 4. Next, we can consider the degree of this differential equation. Here, the equation is not a polynomial equation. with its derivatives, because we know that sine of dy by dx, cos of dy by dx, it is not a polynomial equation. Therefore, we know that the degree of this differential equation is not defined. Next, this is not a polynomial equation in its derivatives. That is, this is not a polynomial equation in its derivatives. Therefore, degree of this differential equation is not defined. Equation is not defined. Next question. Determine degree and order of the differential equation d square y by dx square plus cos of dy by dx equal to 0. In this differential equation, here the highest order derivative is d square y by dx square. Therefore, the order of this differential equation is what? 2. The highest order derivative is d square y by dx square. Therefore, order is 2. Next, we have to find out the degree of this differential equation. Here, this differential equation is not a polynomial equation in its derivatives. That means degree of this differential equation is not defined, because this is cos of dy by dx. That means it is not a polynomial function. Therefore, the degree of this differential equation is not defined. This is not a polynomial equation in its derivatives. Therefore, degree of this differential equation is not defined. Is not defined. Next, we have to discuss formation of differential equation whose general solution is given. Let us consider the general solution y equal to x square plus c. How can we find out the differential equation of this general solution? First, here we have to consider how many arbitrary constant in this general solution. Here only one arbitrary constant, that is c. Next, we have to differentiate it according to the number of arbitrary constants. That is, here only one arbitrary constant. Therefore, we have to differentiate only one time. Then differentiate with respect to x. Therefore, dy by dx equal to what? 2x. That is, dy by dx equal to 2x is the differential equation of this general solution y equal to x square plus c. That is, y equal to x square plus c is the general solution of the differential equation dy by dx equal to 2x. Next, let us consider another general solution xy equal to c square. How can we find out the differential equation of this general solution? Here, first we have to check how many arbitrary constant. Here only one arbitrary constant, c. Therefore, first we have to differentiate this general solution with respect to x only one time, because here only one arbitrary constant exists. Therefore, applying product rule, d by dx of xy, that is x into dy by dx plus y into d by dx of x. D by dx of x is 1. It is equal to what? D by dx of c square, constant. Derivative of constant is 0. That is equal to what? X into dy by dx can be written as y dash or y1 like that. That is x into y dash plus y equal to 0. This is the differential equation of the general solution xy equal to c square. Next question, y equal to a cos 3x plus b sin 3x. By using this general solution, how to find out the differential equation of this general solution? First, we have to consider how many arbitrary constant in this general solution. Here, 2 arbitrary constant a and b. Therefore, we have to differentiate it according to the number of arbitrary constant. That is, here we have to differentiate it in 2 times. Therefore, first, differentiate with respect to x. Therefore, dy by dx or y dash, it is denoted by y dash equal to what? First, a cos 3x. Therefore, the derivative of cos 3x is minus sin 3x. Therefore, a into minus sin 3x. Next, we can considering the derivative of 3x. 3x is what? 3. Plus, next, b sin 3x. That is b into derivative of sin 3x is cos 3x into d by dx of 3x. That is 3. It is equal to, that is minus 3a sin 3x plus 3b cos 3x. Y dash equal to minus 3a sin 3x plus 3b cos 3x. Next, Again, we have to differentiate it because it has two arbitrary constants. Therefore, again differentiate with respect to x. Therefore, d by dx of y dash, it is y double dash, that is d square y by dx square. It is denoted by y double dash equal to, next, minus 3a into d by dx of sine 3x, that is cos 3x, into derivative of 3x is 3, plus, then second term, 3b cos 3x, d by dx of cos 3x is minus sine 3x, that is 3b into minus sine 3x into derivative of 3x, that is 3. That is equal to minus 3 into 3, that is minus 9a cos 3x. Next, 3 into 3, then minus also, minus sine 3x, that is minus 9 into b sine 3x. It is equal to, now here both of them has minus 9 is common, take it as outside. It is equal to a cos 3x plus b sine 3x. It is equal to minus 9. Now here a cos 3x plus b sine 3x, it is what? It is y. Therefore, substituting the value here, it is y. Therefore, y double dash equal to minus 9y. That is equal to what? Y double dash plus 9y equal to 0. Or it is also denoted by d square y by dx square plus 9y equal to 0. That is y double dash is d square y by dx square. Therefore, it is also written as d square y by dx square plus 9y equal to 0. This is the differential equation of the general solution, y equal to a cos 3x plus b sine 3x. Next, consider the question. Form the differential equation corresponding to the function x by a plus y by b equal to 1. Now here, first we have to consider how many arbitrary constant in this general solution. It is a general solution, that because it has an arbitrary constant. Here, two arbitrary constant. Therefore, we have to differentiate it 2 times. Therefore, first cross multiplying, that is bx plus ay divided by ab equal to 1. This can be also written as bx plus ay equal to ab as the common denominator. It is equal to what? Bx plus ay equal to ab. Next, we have to differentiate this with respect to x. That implies what? B into d by dx of x, that is 1. Therefore, b plus a into d by dx of y, that is dy by dx. dy by dx is denoted by y dash equal to d by dx of constant value, it is 0. It is equal to a y dash equal to minus b. Take this side. Therefore, y dash equal to minus b by a. Then again differentiate with respect to x. Again differentiate with respect to x. That implies what? D by dx of y dash, that is y double dash, d square y by dx square. It is y double dash equal to what? D by dx of a constant value, that is 0. That implies what? D square y by dx square equal to 0. It is the differential equation of the general solution x by a plus y by b equal to 1. Next question, find the differential equation of the family of circle with the center at the origin. The equation of family of circle with the center at the origin is what? It is x square plus y square equal to a square. Equation of family of circle with the center at the origin. Origin means 0, 0. Therefore, x minus 0 whole square plus y minus 0 whole square equal to r square, that is radius. And now here we have to take r equal to a. Therefore, x square plus y square equal to a square. That is, it is equal to x square plus y square equal to a square. In this equation, we can see only one parameter or one arbitrary constant, that is a. Therefore, we have to differentiate this general solution only one time. Next, differentiate with respect to x. That is equal to 2x plus, that is d by dx of x square, that is 2x plus, next d by dx of y square, that is 2y into dy by dx equal to what? D by dx of a square, that is constant. The derivative of the constant is 0. That is equal to x plus y into dy by dx is also denoted by y dash equal to 0. That is x plus y into y dash equal to 0 is the differential equation of the family of circle with the center at the origin. Next question, form the differential equation corresponding to the function y equal to a e raised to x plus b e raised to 2x. Then sub question is the state order and degree of the differential equation. Let us consider the general solution y equal to a e raised to x plus b e raised to 2x. Here, in this general solution, we can see two arbitrary constants. Therefore, we have to differentiate two times. First, differentiate with respect to x. It is y dash or y1. y1 equal to, first differentiate with respect to x. y1 equal to what? A into e raised to x. d by dx of e raised to x is e raised to x plus second one b into e raised to 2x into. Now here b e raised to 2x. d by dx of e raised to 2x is e raised to 2x into 2. That is equal to a e raised to x plus 2b e raised to 2x. y1 equal to a e raised to x plus 2b e raised to 2x. It is also equal to a e raised to x plus 2b e raised to x. We can split into b e raised to 2x plus b e raised to 2x. That is 2 times b e raised to 2x. Next, a e raised to x plus b e raised to 2x is what? Y. Therefore, substituting this value as y. Y plus b e raised to 2x. Therefore, y1 equal to y plus b e raised to 2x. Next, y1 minus y equal to b e raised to 2x. Take it as this side. Therefore, y1 minus y equal to b raised to 2x. Then again differentiate. Again differentiate with respect to x. What happened here? y1 can be changed into y2. That is d by dx of y1. That is second derivative. That is y2 minus here d by dx of y. This y1 equal to b e raised to 2x. Derivative is what? b into e raised to 2x into 2. That implies y2 minus y1 equal to what? 2 into b e raised to 2x. Now here, the first one, y1 equal to y plus b e raised to 2x. In this equation, we can get b e raised to 2x equal to y1 minus y. That is, y1 minus y equal to b e raised to 2x. Therefore, substituting b e raised to 2x as y1 minus y. Therefore, it is equal to what? y2 minus y1 equal to 2y1 minus 2y. It is equal to what? Arranging this side, that is y2 minus y1, then minus 2y1. Take this side, it is minus 2y1, then plus 2y equal to 0. That is y2 minus y1, then again 2y1 in this side, it will be taken as this side, it is minus 2y1. Therefore, minus y1 plus minus 2y1, that is minus 3y1 plus 2y equal to 0. This is the differential equation of the general solution y equal to a e raised to x plus b e raised to 2x. Second question is find out the order and degree of this differential equation. Here order is what? y2. That is second order derivative existing here. The highest order derivative is y2. That is order is 2. Here highest order derivative is what? Highest order derivative is y2. y2 means what? d square y by dx square y2. That is order is what? Order is 2. Next, what is the degree of this differential equation? It is a polynomial equation in its derivatives. Therefore, degree will be existing here. What is the degree? Degree is the highest power of the highest order derivatives. Here, highest order derivative is y2, that is d square y by dx square. It has power is 1. Therefore, the degree of this differential equation is what? 1. The power of highest order derivative is 1. Therefore, degree is 1. Next question, form the differential equation corresponding to the curve y equal to a e raised to 3x plus b e raised to minus 2x. Here, we can see two arbitrary constants a and b. Therefore, we have to remove these two arbitrary constants. So, we have to differentiate it in two times. The first one, y1 equal to what? A e raised to 3x into 3. That is derivative of e raised to 3x is e raised to 3x into 3 plus b e raised to minus 2x. That is b e raised to minus 2x into minus 2. That is equal to 3a e raised to 3x minus 2b e raised to minus 2x. It is y1. Next, we can differentiate this one with respect to x. Therefore, again differentiate. That is y2. Again differentiate. dy dx of y1 is y2 equal to 3a e raised to 3x into, again, the derivative of 3x is 3 minus 2b e raised to minus 2x into minus 2. E raised to minus 2x, that is d by dx of e raised to minus 2x is e raised to minus 2x into minus 2. That is equal to 3 into 3, that is 9a e raised to 3x minus 2 minus 2, that is plus 4b e raised to minus 2x. That is, the y2 is also existing in terms of an arbitrary constant. Then here we have to eliminating the arbitrary constant. How can eliminate? We have to consider 9a e raised to 3x can be split into 6a e raised to 3x plus 3a e raised to 3x plus next 4b e raised to minus 2x can be changed into 6b e raised to minus 2x minus 2b e raised to minus 2x. That is 4b e raised to minus 2x can be written as 6b e raised to minus 2x minus 2b e raised to minus 2x. Next we have to arranging these terms. That is 3a e raised to minus 3x minus 2b e raised to minus 2x. Grouping 3a e raised to 3x minus 2b e raised to minus 2x plus next 6 is common, therefore take it as common factor 6 into a e raised to 3x plus b e raised to minus 2x. It is equal to, therefore y2 equal to what? 3a e raised to 3x minus 2b e raised to minus 2x. What is this? This is y1. That is 3a e raised to 3x minus 2b e raised to minus 2x is y1. Therefore the value is y1 plus 6 into, inside the bracket, a e raised to 3x plus b e raised to minus 2x. What is this? This is the general solution y. That implies what? y2 minus y1 minus 6y equal to 0. This is the differential equation of the general solution y equal to a e raised to 3x plus b e raised to minus 2x. Next question, form differential equation of the family of parabola having vertex at the origin and axis along the positive y-axis. Now, the equation of the parabola on positive y-axis is what? X square equal to 4ay. Therefore, equation of the parabola on positive y-axis, equation of the parabola is what? X square equal to 4ay. Next, we have to differentiate with respect to x. Therefore, differentiate with respect to x. We can get 2x equal to what? 4a into dy by dx. Therefore, 2x equal to 4a y dash. Next, 4a equal to what? 2x by y dash. Now, here the equation of the parabola is x square equal to 4ay. Take it as equation number 1. By differentiating this equation, we will get 4a equal to 2x by y dash. Then take it as equation number 2. Next, substituting 2 in equation 1. Therefore, x square equal to what? 4a is equal to 2x by y dash. That is 2x by y dash into y. That implies x square into y dash equal to 2xy. X square y dash equal to 2xy. That implies x square y dash minus 2xy equal to 0. That implies xy dash minus 2y equal to 0. X is common, therefore dividing throughout by x, therefore xy dash minus 2y equal to 0. This is the differential equation of the parabola on positive y-axis.